Hey guys, sorry you missed the lab the other day, the Hooke's Law Lab, but I'm here to just briefly discuss the content, what Hooke's Law is with you before showing you how to use the virtual website to do the lab. So first of all, Hooke's Law deals with objects that have elasticity, so rubber bands, springs, bungee cords, things like that. And the one new term that we're going to discuss today is elongation. You may have already seen this if you've seen elastic potential energy before. Elongation is the letter X in elastic potential energy. It's how far the spring stretches or compresses. So when a spring goes past its elastic limit, which you may have done with a slinky before, it will deform and no longer come back to its original shape. So it's always important to make sure you don't stretch the springs too far. Now, Hooke's law is a relationship between force and elongation. There's a direct relationship between them, so that when you apply a force to a spring, you can see that the elongation, if that's X, if we double the force, we double the elongation. Likewise, if we were to triple the force, then we would triple the elongation. If we were to half the force, we would half the elongation. So Hooke's law is this equation, F equals kx, where F is the force in newtons, x is the elongation in meters, and k is the spring constant in newtons per meter. So just very basic, if we were to take these two scenarios, the same spring, and stretch them two different distances, the spring constant would be the same each time. That's why it's called a spring constant. It should have the same numerical value every single time. If we were to use a totally different spring, that spring would have a different spring constant. Okay, now let's get back to the lab. So for this lab, you will be using PhET's Masses and Springs lab, virtual lab. This is an HTML version, HTML5 version that should work on your iPad, whereas they also have I think it's a Flash version, which you could use on a desktop or a laptop if you have Flash. So I'll show you how to use this. You're going to click on the lab option. And this is what you'll see. This is an energy graph over here. You really don't need that, so you could collapse it if you don't want to look at that. Right now, our spring is in its relaxed position, or what's referred to as the natural length. You want to click this box so that you can see where the natural length is, or the relaxed position, because any drop or stretch in the spring needs to be measured for the elongation. As far as the mass is concerned, there's one mass down here which you are going to hang from the spring. And notice that our spring is kind of bouncy like it would be in real life, but because of this dampening, there's some dampening going on here, the spring will eventually stop bouncing. When we did this lab in the classroom, there was definitely a lot of bouncing going on, and any time that you touched the mass, it would start bouncing again. For this, you could increase the dampening so it stops faster. So now you can use your ruler to measure the elongation from the relaxed position down to the bottom of the spring. So you just do your best to line it up and see where it's at. You might even want to put it really close to the bottom of the spring. So there's your ruler, and you can then change your mass to a different value and then measure the new elongation. So you can do this several times. I would do at least 5 trials. The spring constant bar you are not changing. The purpose, as you saw in the lab that's available online, or if I gave you a hard copy in class, then you have that. But the goal is to find the spring constant of the spring. So you're going to need at least 5 trials to make a graph. Let's see. We don't need to touch gravity, that's good. We don't really need any of this other stuff. That's really all you need. Then if you are in the honors class and you need to find the mass of an unknown. Here's your unknown. You can choose either the red or blue. You do not need to do both. Hang it from your spring, and then measure the elongation. And then you'll have to, once you know what the spring constant is for your spring, then you will be able to calculate the mass of this guy right here. Now, I had asked other students to do a percent error calculation with the mass. The only problem is we don't know what the actual mass value is in this app. So you are not going to be able to do a percent error calculation. So you can skip that part. That's about it. Oh, I did mention a graph. So you would be making a force versus elongation graph so that the slope of the line is equal to the spring constant. Use data analysis, the app we've used in class before, to make your graph. And that way it will give you the slope of the line, which is your spring constant. If you have any questions, reach out to me. Good luck, and I'll see you next time.